Okay, so imagine a particle going along this log curve. It's kind of moving along there. And at some point, it's going to be the closest distance to this origin. Okay, so we want to find where is it going to be the closest distance to that origin. There's a few ways to do this. One way is to use the distance formula and then minimize the distance formula, d. Okay, so we know that the distance to that point is going to be d squared is x squared plus y squared. Okay, and if I want to, I can square root this and do it that way. But if I'm going to make the argument, just make this a little bit easier for myself, I'm just going to make the argument if I minimize d squared, I've minimized the distance. Okay, which is true. So I'm going to get the smallest d squared, which is going to give me the smallest distance. So I need to differentiate this. If I got too many variables, so I'm going to get rid of the y variable and make this x squared plus, instead of y, I'm going to use the position of y given in that form. Okay, so there it is. And I can just find where is the closest point by finding x, and I can find y. So the derivative of d squared with respect to x is equal to 2x plus 2/3 log x times 1 over x. So then there's my derivative of d squared, and I want to minimize it, so I want to find out where the slope of that for this area equation, or sorry, the distance squared equation is equal to 0. So I'm going to end up with 2x plus 2 log x over 2 log x over 3x equals 0, and solve that equation. Now this equation is not that easy to solve because we end up with 2 log x is equal to negative 2 times 3x, which is negative 6x squared. Okay, so this is an equation that we can't solve this algebraically, so we have to solve by graph.